Obviously, connector gauge was sold, PCI was sold. How have things changed over the years in terms of this life cycle of companies and acquisition game?
A lot of the connectors and the catalogs that I have from my dad, I could take a handful of those and okay, now this company, it's been consolidated a lot. Eventually, these companies that gobble up these smaller companies, they get focused on the big picture so much that that's where all these little niches and startups can start happening again. And you start to see it kind of goes full circle where you start to see some underserved markets or areas where 3 or 4 guys can break out of a company and start something new.
I speak confidently on behalf of my partners here that we're of a similar mind, that that's where the cool stuff happens. But I never thought about it in terms of the evolutionary cycle. What's old is new again,
Yeah.
in a sense. And I hope that we inspire some people and that you inspire some people and each of our guests to go out and bravely pursue that, because that's what this is all about. If we stop innovating, I mean, it affects the world deeply in our space that in ways people don't understand. Hey, everybody, this is Chuck for the RF Frontiers podcast. I am joined by my co-hosts, Sean Wallace and Arielle Carlson today, and we have a great guest, Steve McGeary. This is a veteran of the industry with familial relationship and multiple businesses in the RF interconnect space. I think there's an awful lot to learn. We're looking forward to talking to you, Steve. Welcome.
Thank you. It's a pleasure being with you guys today. Looking forward to it.
Yeah, you've got a fascinating history, and I think there's so many of us out there who don't know a lot of the kind of funny stories behind the RF connector industry over the last 50 years. So we're looking forward to talking to you.
Let's kick it off right away. You've been in a lot of places. Where was your first place where you were, and where are you today?
Well, I started out in 1991 at a company called Connector Gage. It was owned by my father, and it was my introductory to the RF industry, microwave industry, as well as prior to that, I was in retail. So this was kind of a whole new world for me, working Monday through Friday and not having to work weekends and nights. It was great. I am a second generation RF and microwave guy. That was my initial start. And now I'm at San-tron, which is a company that's been around since 1955. So I've got a real appreciation for the historical aspect of the connector industry, the background between my father as kind of a catalyst, because I've got all of his history and all of what he taught me, as well as now working for a company that's kind of a museum in itself. Just coming back here has been an interesting thing to enjoy.
It's kind of funny. We talked about in the prep beforehand. You had asked me about how I had gotten started, and I sort of an accidental tourist in the RF industry. You're a less accidental tourist with your father's company, but it seems to be the way. And we talked about in the pre-interview about machine shops and folks accidentally getting into the RF business essentially because they were machining parts for someone or for something. That seems to be a very cool thing. Tell us about some of the history you're aware of in that, and how actually, some of those stories you've come across.
Well, that's kind of where San-tron comes in. They started out in 1955, so they've been around for 70 years, and they started out as a machine shop. And in this area, the Boston area, there were 3 companies really: True Corporation, San-tron, and Delta. They were all started as machine shops, started by Jim O'Neill, who was the founder of True Corporation, Nick Nikitas, who was the founder of Delta, and then Ken Sanders, who was the founder of San-tron. But a lot of the connectors in the early age, back in the 40s, 50s, and early 60s, they were all designs that were fully detailed out and done by essentially Amphenol. If I can just take it back one more step, the very first connector was designed out of Amphenol, but it was designed for the government. And what they would do is they would farm those components out and the connectors to machine shops to build these connectors. So it was kind of a gap between the design engineer and the manufacturers. That's how San-tron started out. Is we were making components. They used to call them UG connectors, which are still around today. But the UG connectors were fully designed. There was no proprietary information. And machine shops would essentially compete for those components in the industry.
That's interesting. So the early RF connectors were what we would call kind of open source today, I guess, right? Is that the
Correct.
right? Okay.
And any machine shop that had the capability of manufacturing those components could add assembly, so they would put them together and assemble them and ship them out to customers in the industry.
So if it started out open source, using Sean's word, was a great one. And then we went through this period of proprietariness, if I can make stuff up, where everybody wanted to have an edge, so they designed their own. But in the end, that open sourceness really has to win out because of the risk to supply for a single source, especially in what is for the government defense world.
Right.
I mean, these things become crucial.
What kind of transpired was eventually they needed better performance. So the initial connectors that were really designed for mechanical reasons, just trying to take the signal from point A to point B, all of a sudden the frequencies were going up and to higher frequencies, and then things were getting smaller. So what the industry did was they came out with mill standards, and that's where the mill standard 39012, which is a connector standard, it used to be mill standard 39012. Now it's called mill PRF. It's performance standard 39012. They started to say, okay, we need to make sure these connectors are performing. So they standardized the connector interfaces to make sure that everybody's connector would mate with another manufacturer, that there'd be no intermatability issues. But they left the rest of the connector design. So all of the transitions down to whatever it was designed for and whatever it was connecting to, whether it be a box with a board inside or on a cable. Those were all left to the design engineers, and that's where San-tron actually hired a gentleman who was an icon in the industry by the name of Red Somerset, but that's what really made San-tron a true connector company, now having the engineering capability to know how to design for discontinuities and performance. That's how a lot of these companies became full-on connector companies.
I mean, I guess that must be how they differentiated, right? If everybody has the same specifications from the government, all you can really do is just compete on price and delivery time, right? There's no other differentiation. So it sounds like, I mean, was bringing in that engineering expertise and performance, was that, maybe you didn't call it differentiation back in those days, but was that the basic idea?
Absolutely. And that's where different companies started to really shine and like you said, differentiate from other ones. Sometimes there were programs that were needing higher frequency, and depending on where they went, they had engineers that knew all the tricks in the trade, how to do compensation formulas to be able to, essentially a connector is a 50 ohm line straight. But the problem is what happens at the interface and then what it's going to, there's usually a lot of discontinuities. And if they're not properly compensated for, you get performance issues. Well, the compensation, that's the whole trick of the recipe, is knowing how to compensate for discontinuities. Certain engineers from certain companies were better than others. And that's how a lot of these companies really started to shine. Amphenol was really the very first, and they were around even when they did the UG connectors. A lot of those were Amphenol engineers that were doing those.
And of course, they were using Smith charts and slide rules, right? This wasn't, there was no CAD, right?
Yeah, and that's a matter of fact, my dad, he designed all of his connectors without CAD. It was all on a drafting board. And which I still have, he had a file cabinet full of cheat sheets on how to do compensations. And different, certain engineers were known. And the funny thing is they all had them. They would all pass them around eventually. But a lot of the formulas that are used and are inundated with the high frequency electromagnetic software today were all done on cheat sheets back in the day. And these guys would, I guess back in the 50s and 60s, they were using slide rule, but calculators. My dad, when he did his compensations to design a connector, it was all done on a calculator.
The thing about the CAD versus the paper, in a way, I think it's a good thing that this came out of machine shops, only because it's really easy to draw on screen. It's really easy to draw on paper. When you blow it up and it's this big, it looks easy.
Right.
Until you try and put it on a machine and actually try and turn that thing. And then you say, oh, wait a minute, it's this big? Well, that wall is less than paper thin. That's never going to survive. But
Right.
It looks so big on the screen. It looks so big on paper. So it's a good thing that it came out of machine shops. So you always had that grounding in reality. Although ironically, as the engineers took over and got involved, and there's that discontinuity between their mechanical design skills and mechanical engineering. They sometimes forget some of that.
Yeah, and other than a few electrical formulas, and there's not a lot of them that are used in connector design, the rest of it's all mechanical. So I've known a lot of engineers in this industry and talked to a lot of them, and the the stronger connector designers typically were mechanical guys that learned the electrical side of the business, which that's what my father was. He was not a degreed engineer. He didn't know anything about the electrical formulas, but eventually he was taught and he had to use those. But all of the problems that usually are connector oriented in a system is because of mechanical failure, not electrical failure.
Don't tell the RF engineers out there. That's our secret. If they knew that it was all mechanical engineers making their life actually work, oh my gosh, that wouldn't go very well.
That's right. Yeah. When I started in the industry, my early, colleagues and mentors said, this is a BNC, this is a TNC, this is an N, this is an SMA. And I remember thinking to myself, what the heck do all these things stand for? Where do these names come from? Right. And I remember Googling it, or back in those days, it was probably Yahoo, but I remember looking around on the internet and there's no real answer. They say, oh, it's the bayonet nut connector. No, it's a British naval connector. It's blah, 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 blah. Like how do those names come about? They're not, they don't seem to be standardized anywhere. It just became like a trade name almost, right?
Yeah, there's a few of the series that have competing legends to them, like the Type N connector, which is one of the most popular. It was designed by a gentleman by the name of Paul Neal, who worked at Bell Labs. The Type N is named after his last name, Paul Neal. And then the TNC, there was a gentleman by the name of Carl Councilman at Amphenol. Well, he got together with Paul Neal and they designed both the TNC and the BNC. And the BNC, some people will say, well, the BNC is bayonet Neal Councilman, BNC. And it's actually what they did was they were going down in size. So there's also history out there that says it's really a bayonet Neal Councilman. That's where the BNC came along. And then you said the TNC is the Navy connector. Well, the TNC, I've seen it listed as the Navy connector as well, but it's really, according to my understanding and from what I've heard, is it's the threaded Neal Councilman. So they made a threaded version of the BNC, and that was done again for mechanical reasons. What happened is the BNC, in high vibration, they'd have some issues with it, and that's where the threaded version, getting a more robust mate, being able to handle mechanical issues that the BNC wasn't able to handle. That's kind of how the TNC came about.
And ultimately, one heck of a lot better connector. They probably ought to call it the terrific NC connector, because the performance ain't even close on a BNC.
Yeah. I don't know, Steve, if you have a Wikipedia editor account, but you might want to do that and go and set the internet straight about where all these names come from.
I knew I was going to be doing this podcast with you, so I've gone on to make sure that my memory was correct to how I've heard it. But there is a lot of information out there about the history of these. If I could just bring up another topic, the history of the SMA, which is by far the largest used coax connector in the industry still today. But there was another group of guys came out of Bendix Research Laboratories. Well, they were the first one to do an SMA connector. It was a BRM connector, which was Bendix Research Miniature Connector. They wanted to go higher frequency and they wanted smaller. But the three guys that were at that place, there was a gentleman, his last name was Bryant, and then there was Cheel, and then there was the third gentleman was McHenry. So those three guys started a company called OmniSpectra. They all came out of Bendix Research Laboratories, started a company called OmniSpectra. What happened is they were actually using the BRM connector, but BRM, they had some changes where they would only spec at 10 gigahertz. These guys started this new company called OmniSpectra, wanted to go to 18 gigahertz, so that put them in the connector business because Bendix Research Labs would only go to 10. So OmniSpectra was kind of the first one, and that's where the OSM, the OmniSpectra miniature, which is the early SMAs, all were started by these three gentlemen from Bendix Labs.
So we talked earlier about how the really early designs were essentially open source, but later on, did companies attempt to patent these different designs, or has it always been an understanding that, hey, these are industry-wide standards?
Well, typically, there's a pro and con to having if you've got a really innovative connector. A lot of companies like to keep that proprietary to the shelf as much as possible. But in order to get large adoption with the military, they had to have second, third sources. So you had that trade-off to try to balance. A good example of that is the GPO connector, which is a Gilbert push-on, which was designed by Gilbert. Well, that was used on a lot of military programs, and it was designed in on a lot of military programs without a standardized interface out there. And what happened is the industry was having issues because as it started to get developed, there were a lot of other companies that were trying to do competitive or comparable connectors to mate to that, but they were having intermatability issues. So Gilbert really dominated the GPO market for years because everybody else's, the performance wasn't as good. And then they finally standardized it. So, that's kind of the pros and cons to having, if you want your connector to be widely used, other than the Gilbert, for the most part, if you don't allow the industry to standardize your interface, it's going to be hard to get it adapted by military programs.
Interestingly enough, on the GPO, when they created the SMP connector, they put not quite enough information
Right.
to be able to design it. Not quite. One of the big things in that is because it is somewhat smaller, and of course they've pressed all the way onto the G4PO now. God bless them. The thing, you can barely see the thing. Don't drop it. The tolerances are paramount.
Especially when you're talking about a blind mate, because there's so many things with the mechanical mating of those two connectors that if the tolerances, they stack up greatly, and if they don't properly bottom, the performance, it just goes to
Yeah, they call it a crash for a reason.
for lack of a better phrase, hell in a handbasket. It just goes away. So,
Yeah.
but
But-
it's my understanding that Gilbert, they finally, kicking and screaming, came to the understanding that interface had to be standardized. And to this day, Gilbert is still a major supplier of SMP, or SMP became the designation for that connector for the industry. They dominated the market for years before it was ever standardized.
So I assume there was a guy named 3.5 millimeter who invented that connector.
Well, again, they stopped naming them after guys,
That's
and
too
they
bad.
started naming them after the 185 millimeter, 292 millimeter, 3.5 millimeter. Those are named for the line size of the connector. So 3.5 millimeter is the diameter of the outer conductor. We used to call them airline connectors, but the 292 is the outer conductor size of the 292, and then the 185, 1 millimeter, etc., etc.
Don't forget the 2.4. How can we forget 50 gigahertz?
Well,
I'm
there's
just saying.
2.4, and then even before the 3.5, there was the 7 millimeter, which was
Yeah,
on all
sure.
the HP test equipment that everybody was using back in the day. And before the 7 millimeter was the 14 millimeter. So they were naming the connectors then by line size rather than by the inventors who came up with these crazy designs.
Well,
Boring.
yeah, that is the industry definitely took a turn for the more boring there, I think, for sure.
Well, there's some companies that tried to keep it, like the 2.92 was, I believe, Anritsu was the one who called it the K connector.
And yeah, well, actually, the 292,
think.
obviously the K was for its frequency range up to initially 46 gigahertz, but most everybody spec'd it to 40.
Okay.
But the 292 was invented by, I believe, Bill Oldfield, who worked at Wiltron, which is Enritsu, but it was in conjunction with Selectro back in the day. So Selectro and Enritsu, to my knowledge, were the first two to have K connectors. They called them, but the 292 back in the day was a K connector. Everybody called it a K connector, but Enritsu, I think, did a trademark infringement or whatever on using the name K. But since they were the first ones, that everybody was calling them K connectors for years before they started just calling them
Oh,
292s.
that's interesting. So if you know, I know a little bit about trademark law. So if you call a connector 3.5 millimeter, you would not be able to trademark that because it's descriptive. So if you call it a K, you would be able to trademark that, but you wouldn't be able to trademark a
Right.
3.5. So maybe that played into it too.
And then the higher frequency ones, the 185 Wiltron called it a V, and then they had the 1 millimeter, which was their W
Yeah.
connector. So they used the frequency band
Yeah.
letter as their connector name and protected that.
I want to know if Paul Neal endorsed the 75 ohm end connector, because that connector, man, that thing is dangerous. Because if you mate that with a 50 ohm, it destroys the connector, right? I want to know what Paul Neal thinks about that.
Yeah, I'm sure that and I don't know the history behind the 75 ohm version. My guess is it probably he may have been involved in it.
Yeah,
But
we used it in TV.
yeah, you're talking about the same series connector with a much different internal guts, and
Yeah,
the contact of the 75 ohm is very fragile compared to the 50 ohm
yeah.
connector.
If you put a 50 ohm male into a 75 ohm female, you've just destroyed that connector. Wait, I remember working in labs, we would always put like labels on all the 75 ohm females that, 75 ohm, don't plug in.
That's what they've had to do with the 2.4 and the 1.85 because they look very
Yeah,
much like a SMA or a 2.92 K
yeah.
connector, but they're not. So, you have this groove on the coupling nut to differentiate the thing. And that probably doesn't stop people from trying that don't know what the groove is. They think it's some fancy, cosmetics or something like that. But the intermutability of the connectors is huge.
The color coding, um, they color code, especially adapters, to different series have a different color because in the test labs, these guys that would be doing the testing, they'd have all of these adapters out here, and after a while, unless you're really attuned to doing connectors, they all look the same, and the thread sizes are very similar. So they try to mate them, and that's where they had issues. But that's where the whole color code came in. That's now a standardized color code for the different adapter series, so they don't have intermatability issues.
Yeah, what I hear though is that all this chaos is, I really think it stems from one of my favorite sayings, and that economics always wins. It may not be in the short term, but in the long term, it always wins. You think you're going to come in, you're going to do something proprietary, and you're going to corner the market. You've got something special. Be careful what you wish for. You corner the market, and then people are going to start saying, "Yeah, but there's only one of you, and that's too risky for me."
I totally agree. And there's another theory on the other side of that coin, but you're right. In a sense, in Gilbert's case, they really, I think financially, they benefited by protecting their interface from the industry. But the other side of the coin is imitation is flattery or whatever. But if you can go out there and you can get other people to start copying what you're doing, but you can initially be the first one out there, you're going to dominate the market, but you're also, from an acceptability standpoint, the chances of growing in volume, the amount of connectors that you're making by allowing the industry to freely have it. That's the other side of the coin that I kind of embrace rather than try to protect it so much like they do. Eventually, they're going to figure it out.
Mm-hmm.
The first thing you do when you got a design request from someone, they'd say, "Hey, I'm tired of dealing with these guys, or they've obsoleted this connector. They won't sell it to me." So the first thing the engineer does is he gets a sample of the competitor's connector and he reverse engineers, takes it apart to try to see what they do. I think that's a common thing. There's nothing illegal about it, but I would say that almost all connector designers, to some degree, get their competitors' parts, take them apart, and see what the heck they're doing internally.
If you think about it, each connector is like designing a category. So, there was the original connector, the UG connector. In my head, I'm saying it's the OG connector, original gangster, no doubt about it. It should be renamed the OG just for all perpetuity. It makes me feel
Maybe you should be a Wikipedia editor.
But
Go do
every
that.
time yeah, there you go. Every time you design a connector, you're essentially designing a category, right? It's this new thing that's highly differentiated that nobody else has. But the beautiful, and you reap the economic rewards by a massive amount, massive forever. But whenever there's a new category design, there are always going to be imitators. And that's really how you know that you've done something unique, that you've actually designed a category, because people start copying it.
Right.
Otherwise, they go, well, that thing sucks, and I'm just going to go do something else. That's not worth my time.
Yeah, exactly. There's a lot of new connectors out there now that aren't standardized. There's a big push for ganged mounting, where
Oh, yeah.
instead of it being a discrete connector, they're ganging them in blocks and stuff. And they're usually using standardized internally designs, like the GPPO or the SMPM connector. What they do is they're taking those and they're putting them in gang blocks so that you can get them in a lot less space because of the space design. And that's all well and good, but once you start ganging them like that, you're losing that intermitability issue. So with the ganged connectors, a lot of different companies are offering them now, but in the multi-port blocks, they don't mate with one another. So they're, and they're not standardized. So that's,
Mhm. Yeah.
the industry hasn't addressed it, but you're starting to definitely see a lot of new connectors coming out that aren't standardized in any
Are you
way.
talking about the connectors you see on backplanes, like a VPX backplane or something like that? Is that where you see those ganged connectors?
A lot of them, yeah, and a lot of the that's where the high-speed digital market. When I was working for Samtec at one time, which now they're in the RF microwave connector business, but prior to that, they're really high-speed digital company. They're from they're all looking at testing boards and testing silicon chips. That's where they need the space on the board. So the gang mount series is a big popular design for that marketplace. And now that those are all being used on military programs now, because a lot of the things that the high-speed digital guys would, when it came to space, is now very, very important and used on a lot of mil programs. That's where the Vita is standardized. The Vita is the one where you see multi-ports, and that's a military program. The Vita standards are standardized, but there are a lot of non-Vita versions now that are being accepted and used on military programs where there's no standardization.
Even in that instance with the Vita 67.1, that was an instance where somebody tried to corner the market with something new.
Exactly.
TE Connectivity came out with something that they basically patented. And they said, no mas, that's not going to work for us. And the next thing you know, there's an open source version. And to this day, they're not intermatable. And now they're already going on to yet another version, which is essentially open source, if you will, for exactly that problem. It's economics always wins.
You're right. Economics always wins, and economics is usually what really eventually drives standardization. Because you talk about the military with their standardization on the programs, but high-speed digital world's the same way. They've got a lot of standardization now too, that was driven by a connector that was adopted by the industry by what they wanted, but they demanded second sourcing, and that's what creates the standardization.
So let's shift gears a little bit here. I'd like to shift back more to this history side. You've got a lot more to your experience than simply the history of connectors and the technology of connectors. And although, frankly, I could geek out about that for another hour and a half, personally. But you said you started out with connector Gage, and about how your dad got started. But you have such an interesting career as it's evolved. It's not like you're still with connector Gage. You're with San-tron now, and there have been a number of iterations of things going on in between. How did that launch your entrepreneurial career? That journey starting with the family business.
Well, when I went to work for my dad, and again, I was out of retail, so this was all new for me. But I had my business degree, and so I said, okay, I'm gonna, obviously, since it's my father's company, it's going to give me access to getting to learn everything about this business. But I never really went in there with the intention of learning and starting up other companies. I just went in there saying, okay, I want to learn everything I can about this business. But the fact that it was my father's company, I think from an entrepreneurial standpoint, gave me an edge or a lot of impetus in saying, hey, I know what dad did. So as he eventually retired and sold his business and I went away, in the back of my mind, I always had a complete picture of what it takes to start a business, knowing that There was a lot of things that maybe I wasn't directly involved in, but I had enough involvement where I was pretty comfortable either hiring people that could do it, but I had a really good understanding of what it was going to take to start my own business. Connector Gage was kind of funny. He had worked for a lot of big connector companies over the years, but his gimmick to try to start his own business was interface gauges. That's where the name Connector Gage came from. He really wanted to do a custom connector house. He wanted to be able to offer custom connectors to knowing that a lot of the standard connector companies required large quantities or long lead times to do custom connectors, but that was a real need for that. But he wanted to be able to get in the door, and he felt that if he did interface gauges, which other than Maury, Connector Gage, I think, was the only one that was doing interface gauges in the back time. But he thought if he could get into the lab and they all needed connector gauges, it was his shot at getting into customers and maybe getting a chance to do some custom connectors. So that was kind of his mind behind starting Connector Gage, which I thought, okay, I understood that. I think it's limited today, knowing what I know, that's limited, but it always made me think that I don't want to just be another connector company that, hey, I'm starting a company, I'm doing connectors, coax connectors. You have to have a unique thing that you can offer customers that you can build a business on. So when I started PCI, which was the company that I left and sold to Samtec, I say I had two partners, so it wasn't just me, but the three of us, we wanted to focus on not just another connector company, but the low loss cable market, which I know you're familiar with, Chuck, because that's where you're at now. But the low loss cable assembly market, there was nowhere to go to find low loss connectors that were compatible with most of these cables that people were providing low loss assemblies. So my main focus at Precision Connector was high frequency, which those were hard to find, but also we were focused on trying to cater to cable assembly houses that needed connectors for low loss cables. And out of that, that's how PCI really built its business. But it was niche. Nobody else was doing it. So, my advice to any entrepreneur out there is find an unserved market that's hard to find product for. And if you can go out there and find those gaps, that's where your best bet is succeeding rather than just being a me too.
So you mentioned earlier that you didn't start out as an engineer. You started out working for, I think you said a consumer company. Remember you mentioned in the pre-interview you were doing finance or something like that. Is that right?
I was selling shoes. I was a shoe
Selling
dog.
shoes. All right.
I was in the retail business. Matter of fact, one of the first designs I did at PCI till this day, this is going to date me, and some people will understand the reference, some people won't. We called it the Al Bundy design after Al Bundy from Married with Children. But
Thank God I'm not the only one thinking it, Steve.
I was a shoe.
Is your wife named
I don't know what
Peg?
you're talking about.
That one design was probably PCI's. Probably it's definitely one of its top 5 sellers that we sold to help build that company. Was the Al Bundy design. After we sold the company, and it's not like I was retiring, but the company was moving. So, but the people got together and they got me a gift, and it was a crystal cross sectional cutout of the Al Bundy design connector, which I still have today. So I came from the retail business, and again, what I would say to the guys in the industry, I'm not an engineer. I'm obviously a curious person who likes to learn, and I've learned a lot of the engineering behind connector design. But you don't have to be an engineer to succeed in this industry.
Because I wanted to go back to that as someone who, like, just the RF industry itself is super new to me and not my background at all. But I think that's really important, and just to be able to say that you don't have to come from a background like that. But there are certain, I think, characteristics of someone that allow them to switch industries like that. Would you have switched into the connector industry, RF industry, if your family business had not been there, was that an easy switch because it was a family business? What qualities of yourself really allowed you to be able to make that switch and thrive?
I was always a sales guy, so I always wanted to sell whatever it was I wanted to sell. And obviously it was shoes at one time, but I've had other sales jobs in other industry, but I was always a sales guy. But if it wasn't for my father, working for my father, I don't think I would be in the RF industry today. The other thing is, it was a real challenge for me because it's a very hard product to learn about, especially when you're not technical.
Yeah.
But I overcame that challenge. Now, it took time, but I mean, I didn't even know how to read or print when I first came to the industry. I had catalogs that I delved into. My dad had this huge catalog collection. So I was using that as well as him. He was always there to answer questions, but I would go out on the road and try to sell these things and I wouldn't know what I was talking about. The one advice that I would say is I never went in front of a customer, pretended like I knew more than I did. So I knew how to sell and I knew how to talk to people and I knew how to develop relationships. But a lot of what I learned from my customers, especially from an application standpoint. You know, the connector is one side of it, but how it works on an application is a whole nother learning experience. So you just have to go out there and continue to build your knowledge by being immersed in the product in a sense and how it's used.
Yeah.
So it's not just I wasn't out trying to sell. I was out
And to
trying to say,
learn.
hey, I'm the representative of the company and I'm in sales, but tell me what you do and what connectors do you use? And well, why do you use this one over that? I learned a lot more from my customers, from the catalogs in the industry, et cetera, and then from just asking questions. That's kind of how I
I think that's
in a sense, got to be, from an engineering standpoint, an expert in
I think
connectors.
that's a really important point that I know we've said before on other shows, but that you working with customers, you really need to learn from them and have them tell you, whether it's educating you or when you're trying to sell something, of what their needs are, which a lot of companies I don't think do that. And they just try to go and tell the customer what they need. And that's just not the case.
Yeah, I think
Yeah,
there's a lot of
and it's
engineers
funny
who
because
want to do that too. So I think there's a lot of engineers who want to tell the customer what they need. And so maybe in some ways, the fact that you didn't start out as an engineer was an advantage because you were already a really good listener.
well, it's funny because Sean, I know you're an educated engineer and you know your product real well. You said you don't know much about connectors. Some of my best visits were guys that didn't know a lot about connectors because eventually I knew a lot about connectors. So it would be a combination of going back and forth. Hey, what are you doing? Why do you use it? And then they would ask me connector questions that they didn't know about, and I had the answers. I had the knowledge. I had the background. So a lot of times those were my best visits were customers that we were both feeding off each other from my connector expertise and then their expertise on their product and how it's used and why this connector actually matters to them.
Mhm.
So it's kind of you feed off each other.
So I'm just kind of painting a picture in my head, right? So your dad had run this business for years, for decades. You are the son of the boss, and you show up for work one day with a bunch of blue collar machine shop guys, right? And say, "Hey, I'm the boss's son. Teach me everything you know." Right? That is, I can't imagine the whispers that were going on in the shop. What did that feel like to be on the other side of that transaction or that situation?
Yeah, I mean it's definitely a bit tough in a sense that um, for the most part paternalism in any kind of industry is frowned upon by the people that really make it hum. But what I tried to do is I went in and I tried to learn and I treat everybody with respect. I also got involved. So there was no job that was beneath me from taking the trash out, but I was out in the machine shop doing secondary work. And I remember I was drilling a hole in a contact as a secondary operation, something they couldn't get off the primary machine. So I had these thousands or so, and I'd sit there and I would drill and blow, and I would do the secondary operation for hours on a time. Finally, get the basket done, and say, "Okay, guys, here these are done finally." And then they'd all laugh and bring another basket of a couple thousand for me to do. Baptism by fire, I guess, but you got to get involved, and I I learned from those people. I relied on those people, but I treated them with a lot of respect. And I think because of that approach, rather than, hey, I'm up here and I'm the old man's son and you better listen to me. I never took that approach on people. I tried to say that I wanted to learn this business. And obviously I was my father's son and I certainly had advantages there. But when it came to doing the work and doing the job, you know, I was out there with everybody, whatever had to be done, I was out there to participate.
Yeah, in technology today, they have this thing they call, especially in software, a full stack developer or a full stack engineer, right? So you were essentially a full stack engineer. You were going, you could either sell it, right, or analyze the economics of each connector, or then you can, another day, you're out on the floor drilling holes in it. I mean, that's a full stack employee or full stack engineer, whatever you want to call it. So maybe that's the secret, is knowing, being totally vertically integrated in your own knowledge.
Well, and understanding all the vertical integration, I mean, I lacked the electrical knowledge and the technical knowledge from an engineering standpoint and degree, but it wasn't long before I knew how the parts were being machined, the different areas where there might be burrs and stuff, and knowing where there was problem areas of a connector, as well as how the parts went together. Saying, yeah, the way that these are put together, if you don't do it right, you get this problem. And so sometimes a customer would have a problem with the connector, and I go, yeah, I can probably tell you what's going on there. The assembler's doing this or that or something. So
Yeah.
it was my way of knowing the whole side of how the connectors were manufactured.
I suppose it also allows you to price them a lot more accurately too, right? Um,
Yeah, pricing is another part of it, but yeah, you know the costs. And again, that's the other thing you mentioned earlier about the engineer and coming from the machine shop, not over tolerancing it. When you design these things and you put these tight tolerances, your cost goes up too. So you should only do it when absolutely necessary. The whole business itself, from cost and everything, and all how this is made, it all has an effect on one another. And knowing how these effects ripple down certainly makes you a lot more useful to your customer out in the field.
Talk about the full stack engineer and the vertically integrated in seal sense. I mean, we often have this recurring theme about innovation coming from small business. That is the personality profile of the business. That's the personality profile of the employees in a small business, period. There is no one who is a single tasker. If you start a business, if you thrive in a small business, you literally have to have ADHD. How else could you survive? You also have to be one hell of an organized individual or you're going to sink. Just because how do you keep up with I say oftentimes, I'm like a puppet with horizontal strings. It's just, if people aren't pulling in that direction, then the work and the tasks are.
yeah.
And you have to be.
Yeah, I love that, Chuck. It's, I don't know if you can be vertically integrated in a large company, right? In a large corporation, you tend to have a very specific role and a specific scope, and you're not supposed to go outside of that. So it's interesting. Maybe a small business is where you need to be if you want to be a vertically integrated individual or a full stack individual.
Yeah, and that's where the entrepreneur side comes from, I think, is because you get exposed in a very detailed way to a lot of stuff that in a big company, when you've got this little piece of the pie that you're responsible for, and they don't let you, not only if you wanted to go outside and learn the other side, they don't allow you to. So I think the smaller companies tend to breed more entrepreneurships. And it's funny because getting back to the connector industry and a lot of the connector companies, most of the connector companies were smaller companies. And then a few of those guys would break out and they would start another company. But there was a lot of startups that came from companies that were, say, 50 people or less, rather than these people where you've got thousands of employees and you get stuck in this little department. That's all you do all day.
Before we got started here, Steve, you had asked me about my background. I told you a story about a fellow by the name of Jeff Matlack, and he was my boss at Lucent Technologies back at the turn of the millennium. And Jeff gave me a piece of advice, and he said, be a generalist. And he's working in Lucent Technologies, where everyone is a PhD specialist, and I very definitely was not. I was a bachelor degree generalist. He said, do it and do it purposefully. I've never forgotten it. I followed his advice. What I did not realize until this very moment in this aspect of the discussion is Jeff said, get the hell out of big business and go work in a small business because that's where you're going to shine
Right.
as a generalist. And my career has fortunately taken me in that direction. Indeed, I certainly thrive more in a small business environment than a large business environment.
Yeah, no question about it. And you know, when you say that being a generalist, but also be curious to, and I think by being a generalist, it almost forces you to be curious, where you got to know a little bit about everything.
Yeah.
So don't get stuck in the weeds. And it's fun to get in the weeds, and you do learn more when you do that. But you've got to know a little bit about everything, and the things that you tend to shy away from, don't shy away from it. Try to at least get involved to some degree where you learn a little bit about it, at least how it fits into the big picture where you know, and that way you'll, tend not to make mistakes. You also tend to also appreciate those people that do take care of those little things that you don't want to be directly responsible for.
So let's shift gears a little bit. So as I said, you've talked about connector gauge and you've talked a little bit about San-tron and PCI. Connector gauge was sold. PCI was sold. How have things changed over the years in terms of this life cycle of companies and acquisition game and investments by other companies? How have things changed from all that long ago to now?
Well, there's been a tremendous amount of acquisition. Obviously, a lot of the connectors and the catalogs that I have from my dad, I could take a handful of those and okay, now this company, it's been consolidated a lot. So there's farther and few connector companies as there used to be. I don't know if that's a good thing or a bad thing. I think in a sense, what you're probably going to find is, and what I hope to see is eventually these companies that gobble up these smaller companies, they get focused on the big picture so much that that's where all these little niches and startups can start happening again. And you start to see it kind of goes full circle where you start to see some underserved markets or areas where 3 or 4 guys can break out of a company and start something new. I still think the barrier to entry in our industry is not that high where go-getters can really still go out there and start a company today.
That's incredible. Honestly, I think I now have a crush on you just for saying that. So I'm not afraid to tell the world just because I think that we're certainly of a similar mind. I speak confidently on behalf of my partners here that we're of a similar mind, that's where the cool stuff happens. But I never thought about it in terms of the evolutionary cycle. What's old is new again.
Yeah.
In a sense. And I hope that we inspire some people and that you inspire some people and each of our guests to go out and bravely pursue that because that's what this is all about. If we stop innovating, I mean, it affects the world deeply in our space that in ways people don't understand.
It does. And now, I mean, the technology today is just, the pace of change is unbelievable. But it never ceased to show me. I'm a graybeard now, officially a graybeard. So it's very easy to stereotype and come up with quantifying and classifying, hey, this is the way it is. But I've never ceased to be amazed when I meet some of these young engineers and young people. Yeah, they do things differently, just like we did things differently than our parents, but they're smart people. And I got a feeling that you're going to see a lot of these younger engineers and younger generation. I don't think they're going to be pigeonholed to some big conglomerate and just being happy working for them. They're going to want to do their own stuff. And there's a lot of creativity that you'll see startups still happening again and again and again.
Thank the good Lord. Thank the good Lord. Well, this has been incredible. I mean, yes, I'm an interconnect geek, so guilty as charged. So maybe particularly special for me. So, but do you have any closing thoughts for us?
I guess the only closing thought, just on the thing we were just talking about, is I remember the industry. The first time I was really introduced to the industry was at an IMS show in San Francisco. I wasn't even working for my dad yet, but I went to one of the shows with him. I was still in college, and it was it was kind of like, I don't know if it would call it high school reunion or frat week, but I was just amazed at going to the IMS show and the amount of people that he knew and the amount of people that knew him, all from all these different companies, but they were like buddies. And it was the IMS used to be a real industry party where it was everybody had these relationships that were firmly established over the years. And it's different now, the digital world and the text world, and I'm not going to say it's worse because my kids say, "Dad, we still communicate. We just communicate in a different way," and I understand that, but I hope they don't lose that personal touch, because to me, when you're talking about startups and you're talking about that, developing relationships with people in our industry are so important. That's what I have the most fear of, in the sense that it's between email and everything else, the way that we talk nowadays. Before it was all telephone. You always had a telephone and you would talk on the phone, but you would not only talk about what they needed, but you knew maybe what their kids were doing or this, that, and the other. There was more of a connection outside of just work and that focus of building relationships with people. That's what they have to be careful of. And to me, if you can build relationships with people, that's going to be a true skill that's valuable as we get more and more digitized and more into this world that we live in today, where it's all non-personal.
Yeah. Yeah, that certainly resonates with me, Steve. Email is too efficient sometimes, I think, right? So,
Yeah.
yeah.
My kids would say, "Spoken like a true
Yeah.
boomer." So,
Well, I think it goes back to just the whole full circle of not just in your partnerships, but in people that you're trying to work with and sell to. The best way that you can know their needs is by knowing them and understanding them. And you can't really get that through an email. You can, but just the personable aspect of that is not there.
people like doing business with people that they like. It's
Yeah.
Amen.
still relationships. And there's a really good book that I read last year that I'm scrolling through. I don't know, it was either Facebook or something, but I believe it's called The Go Giver. And it just talks about how to be successful, which they've got this story where your goal should be, how do I help this person? So rather than become a salesperson, you become a problem solver for people.
Mhm.
And once you once you can talk to a customer and they've got trust that you're really trying to help them out and solve their problem, you're not selling anymore. And then once you get that reputation, they pass it on to others, and then those people that have those problems, they send to you. But that's, to me, that's the best way to get credibility, is trying to help people.
Yeah.
Try to help solve their problem.
Yeah.
In other words, be a good person and a good human in every sense of the word. Funny how it comes back to that.
Yeah.
We're almost on the eve of IMS in Boston, the week of June 8th, I believe. With that, I hope that we can all get up there and make it about the people, honestly. Be that good person and see how we can help each other. I think that'd be the greatest thing. We have a little less frat party, but hey, if that's your thing, then go for it. That won't be me.
There's still a lot of NA beers out there that are pretty darn good nowadays. So
Yeah, there's no NA scotch, but whatever.
actually, there is. I know there's an NA bourbon. I had an NA bourbon down here in Newburyport because I don't drink anymore either. I went to a place and I love bourbon, and they had an NA bourbon, so I had to try it. It was like $14, but it was terrible. But they do have a lot of NA beers that are good nowadays. I had a Guinness over the weekend, which is a Guinness
That's very good.
Zero, and
Yeah.
it's good stuff.
Well, on that ringing endorsement or non-endorsement for NA bourbon, uh, thank you on behalf of the RF Frontiers team, Steve. You're the best. Looking forward to seeing you in Boston. And if you want to get in touch with Steve, check the show notes. You're going to see everything you need to see. And we will see you next time on our Frontiers podcast. Dream big.